Welcome to EPG Pathshala. Today we are going to discuss the production of biogas and its application. Biogas is a product which is obtained during the anaerobic digestion of biomass materials that includes the excreta from the animals, that is cattle dung, pig waste, poultry waste, etc., and crop residues which are of softer nature like straw of rice, straw of this wheat and water hyacinth, etc. And during the anaerobic digestion process, it is converted into a mixture of carbon dioxide and methane, having about 60% methane, and mixture is called biogas. Its heating value is much lower as compared to the petroleum gaseous fuels like natural gas and LPG, but still it has the good heating value for its application as thermal as well as engine applications. To an anaerobic digester that treats farm waste or energy crops, the biomass in the process is converted into gaseous fuel called biogas. These plants can be fed with energy crops such as maize silage and biodegradable waste, including sewage sludge and food waste. During the process, an airtight tank transforms biomass waste into methane, producing renewable energy that can be used for heating, electricity generation, and also for many other applications like industrial feedstock, etc. The slurry which is obtained from the biogas plant is more richer in nutrition and is an excellent organic farm manure. The next is the type of biogas plant. The most important type of biogas plants used in India are Janta fixed dome type, and the second is KVIC floating drum type biogas plants. And this Janta biogas plant is further divided into Deen Bandhu fixed dome type plant and Shramik Bandhu biogas plants. Now the KVIC plant, which is a floating drum type of plant, initial cost of installation is much as compared to more for the Khadi Village. KVIC means Khadi Village Industry Commission, and its initial cost is a little higher. Cost of repair and maintenance during operation is relatively high. The steel gas holder needs to be replaced due to corrosion effect. That corrosion is generated due to the water vapors and some organic acids formed during the anaerobic digestion process. Life of digester is expected to be 30 years and that of the gas holder is 5 to 6 years. This means that it needs replacement of the gas holder uh, after every 5 to 7 years throughout the life of the biogas plant. Drum which is exposed over the ground does not allow the use of space over the plant for other purposes. As the gas holder is metallic, the low temperature during winters affect the gas production. Now this means that because of the lower temperature, lower atmospheric temperature, the temperature of the slurry, because of the metallic holder, gas holder, the temperature of the slurry drops, and the low temperature affect the gas production and the bacteria's uh, as a whole. The gas production in winters drops significantly in KVIC plants. It is most suitable for cattle dung and night soil, other organic material, and may clog the inlet pipes. So, the crop residues like straw, etc., if they are not properly ground, can cause the operational problem in KVIC plant. But it is suitable for animal excreta and the night soils. Construction of digester is simple and hence no skilled labor is required, but fabrication of the gas holder required workshop facility. It requires less excavation work during installation. Location of defect in gas holder and its repair is easy and can be done in the workshop. Release of gas is at constant pressure because of fixed weight of steel, gas holder, and hence efficiency of the plant is higher. Now these are some of the photographs of the KVIC biogas plants. This black one which is visible, now this is the gas holder which moves up and down depending upon the quantity of the gas stored in the gas holder. This is another KVIC floating drum biogas plant. Now this is another biogas plant, and this plant is having a capacity to generate gas for operating a 1 megawatt engines. So this whole plant is 1 megawatt electricity generation system using biogas and is operational at Ludhiana. And the feedstock for this biogas plant is the dairy waste. Now the main characteristics of fixed dome type biogas plant. Now in case of fixed dome type biogas plant, capital investment for corresponding size of the KVIC plant is less. As there are no moving parts, the maintenance cost is low. Steel gas holder is not required. Life of the plant is expected to be comparatively more. As the unit is underground, the space about the plant can be utilized for other purposes. And effect of low temperature, especially in the winters, is less in fixed roof type of biogas plants as compared to KVIC plants. Construction of dome portion of the unit is a skilled job and only trained masons can do it. It requires more excavation work. Location or defect in the dome and their repair is difficult. Release of gas is at variable pressure and it may cause a reduction in efficiency of the gas appliances. It could be easily modified and adopted for use of other types of organic waste. These are some of the photographs of fixed tube type biogas plant. Now this is a this picture shows the different construction stages of a biogas fixed dome type biogas plant uh, with a capacity of 100 meter cube. Now next is what is biogas. Biogas is typically refers to a gas produced by the biological breakdown of organic matter in the absence of oxygen. Biogas is produced by anaerobic digestion or fermentation of biodegradable materials such as biomass, manure, sewage, municipal waste, green waste, plant material, and energy crops. This type of biogas comprises primarily methane and carbon dioxide. This is the composition of biogas plant, that is methane and carbon dioxide. Methane is 60%, carbon dioxide around 40%. It contains hydrogen sulfide, which is less than 1%, and hydrogen is 1 to 2%. Heating value of biogas is 18 to 20 megajoules per meter cube. Now, biogas application norms. So, these are the norms which have been arrived at based upon experience by so many persons. For cooking of one adult person, the gas requirement per day is 0.4 meter cube. For lighting a 100 CD intensity lamp, the gas requirement 0.12 meter cube per hour, and for engine operations, the gas requirement 0.5 meter cube per horsepower or 0.75 to 0.8 meter cube per kilowatt hour electricity generation. Now, the parameters for designing a biogas plant, this is also based upon the data which is available in the literature. Now, the dung obtained from one cow is 15 kilogram per day, and the dung contains a total solid content of 16%, and biogas production from the dung is 0.04 meter cube per kg of fresh dung. Hydraulic retention time, that is considered as 40 days. Actually, in fact, this is a function of the atmospheric temperature. In hilly regions where the ambient temperatures are lower, the hydraulic retention time is considered as 50 days for the completion of the biogas production cycle. In other plain areas, it is 40 days. Now, for preparing the seed or feed slurry into the biogas plant, the dung is to water ratio is 1 to 0.8, and the density of slurry obtained is 1100 kilograms per meter cube. Volume of gas holder, that is for KVIC plant, is 60% of the total capacity of the plant, and the volume of digester, whatever we calculate, so keep 20% in excess of that design value. Now, this example shows the design of a biogas plant for meeting the cooking requirement of a family of 6 adult members, running an engine generator of 5 kilowatt capacity for 4 hours a day, and we have to determine the quantity of biogas required per day, B. Quantity of cattle dung, number of cattle required, C is the volume of biogas plant holder, and D is the volume of digester. Now, for solving this problem, consider the basis of calculation as 1 day of operation of the system. Biogas for cooking, assuming 0.5 normal meter cube per person per day comes out to be 2.4 normal meter cube per day for 6 persons. Now, considering the operation of diesel engine generator set consuming 0.75 normal meter cube of biogas per kilowatt hour generation, the total gas requirement for running a 5 kilowatt engine for 4 hours a day comes out to be 15 normal meter cube per day. The total biogas required in these two applications comes out to be 17.4 normal meter cube per day, or let us say for design purpose 20 meter cube per day. So this means we have to design a biogas plant for 20 meter cube per day of total gas production. Now B is the kettle dung required, assuming that 0.04 meter cube of biogas production per kilogram of fresh dung. The total dung required comes out to be 500 kilograms, and considering the 15 kilogram of dung produced by one kettle, the total number of kettles comes out to be 33.3, or let us say 35. So 35 kettle are required to produce the dung, which is enough for producing 20 meter cube of gas per day. Water required to prepare the digestion mixture or seed slurry, assuming 80% of water required based on the weight of the dung. That comes out to be 400 kilograms, and the total weight of the digestion mixture, thus 500 plus 400, comes out to be 900 kg. Now, volume of the digestion mixture per day is the total feed slurry digestion mixture divided by the density, which is assumed as 1.1 grams per centimeter cube, and the total volume comes out to be 818 meter cube. Now, volume of the digester is the volume of digestion mixture, that is meter cube per day, multiplied by the hydraulic retention time plus the free space in the digester. Let us take the free space as 20% and hydraulic retention time as 40 days. So the total volume of the digester comes out to be 39.3 meter cube, or let us say 40 meter cube. So volume of the gas holder is 60% than that of the plant capacity, that is 20 meter cube is the plant capacity, so 20 multiplied by 0.6 is 12 meter cube. So this way, for any specific requirement, the biogas plant can be designed accordingly. Now, the biogas which is generated from the biogas plants contains 60% methane and around 40% carbon dioxide. Now, the carbon dioxide from the biogas generated from the plant can be processed to remove the carbon dioxide, and that removal can take place uh, by means of water scrubbing at high pressure, and that may be followed by chemical absorption to remove the carbon dioxide. And once the carbon dioxide is removed from the biogas plant, it is more or less the methane, and its characteristics resembles with that of natural gas. That means that the processed biogas. Now, this slide shows the composition of the processed gas. So, now this processed gas can be utilized uh, in place of natural gas. It can be used for uh, it can be used as a fuel in kitchen for cooking purpose. It can be used for running the automobiles, and it can also be used as a fuel in stationary engines, as in case of the natural compressed natural gas. Now, some uses of biogas. It is visual improvement in rural hygienes, environment benefit on a global scale, protects the Earth's natural resources, renewable and decentralized energy source, widespread availability of dung in rural sector of the country, eco-friendly energy production, boom for the rural economy. Biogas can be used for thermal application. It can be used as a fuel in furnaces, in small and medium industries. It can be used as a fuel for cooking in domestic sector. It can be used for running the engines. That means it can be used to run a spark ignition engine on the gas alone, and it can be used as a supplementary fuel in any CI engine or diesel engines. Some of its chemical uses, it can be used for hydrogen generation, and it can be used for the production of methanol. This picture shows the application of this biogas technology. Now, the main raw material for biogas production is the animal dung. Its traditional application is the production of dung cake and the application of dung cake as the fuel in domestic sector for cooking purpose. Now, in application of dung cake in domestic sector for cooking leads a lot of smoke formation during the combustion of the dung cake and creates a very unhealthy and unhygienic conditions, environmental conditions in the kitchen. Now, if the same dung is converted into biogas through anaerobic digestion process and is used as a kitchen fuel, so the picture shows the clean, absolutely clean environment in the kitchen. Second number is that efficiency of combustion of biogas for thermal application is much higher as compared to the combustion of the dung cake in the biomass cook stoves. The biogas is the byproduct. Biogas is the product obtained during the combustion of animal dung and some selected crop residues. Now, these materials traditionally are used as a fuel and manure in very inefficient way. And if the same material is used after its anaerobic digestion, during the process of anaerobic digestion, it is converted into a biogas, and the residual slurry, which can be used as farm manure, is much more richer in nutrients as compared to the original waste material. And the biogas can be more efficiently utilized as a fuel in domestic sector. It can be used for running the engines, and it can also be used as a feedstock for some of the chemical industries. Thank you.